I am Bhaskar, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. In today's class, we are going to see inverse Z transforms. Already we have discussed Z transforms. Now, what is inverse Z transforms? I will tell. While telling Z transform definition, I already explained what is inverse Z transforms. Inverse Z transforms. Inverse Z transforms. Right. If already we know that if Z transform of un equal to u bar of z, if Z transform of un equal to u bar of z, then Z inverse of u bar of z equal to Z inverse of u bar of z equal to un. Z inverse of u bar of z equal to un is called the inverse Z transform of it's called the inverse Z transform of u bar of z. Right. I'll write some formulas. Already I explained the formulas in Z transform whatever you are writing. So that one just left hand side terms we'll write right hand side terms we'll write left hand side, and we'll put that Z inverse. Right. The formulas already we discussed this one. Formulas I'm writing here. Formulas. First one should be Z inverse of z by z minus 1 is nothing but 1. Next, z inverse of z by z minus 1 whole square is nothing but n. Z inverse of that means z inverse of z square plus z divided by z minus 1 whole cube. So that equal to, I'll write it as n square. Next one should be z inverse of z cube plus 4z square, z cube plus 4z square plus z divided by z minus 1 whole power 4, that equal to n cube. So we remember, so one more formula also, right? First I will simplify this, right? Now for this, using damping rule, already we have done the damping rule. Using damping rule, how do you write this one? See, this general formula I will write. Fifth one should be z inverse of z divided by z minus k equal to k power n. Next, z inverse of kz divided by z minus k whole square equal to k power n into n. Next, z inverse of kz square plus k square z divided by z minus k whole cube equal to k power n into n square. Next one should be z inverse of kz cube plus 4k square z square plus k cube z divided by z minus k whole cube equal to k power n into n cube. Right. This is the formulas. Already we derived in the Z transform. That only we are taking here in the inverse Z transforms. Already I derived Z transform of n. What is that? N square, n cube, and Z transform of 1. That are all we derived. And these formulas we got it from the damping rule. So here damping rule we are applying in the inverse Z transform. Right. Now, using these formulas, we will simplify First, in this one, only two concepts are there. One is how do you simplify the partial fraction problems using inverse Z transform, and another one should be how do you simplify the difference equations. Difference equations. In the difference equations, we will apply that initial and boundary conditions. Afterwards, it will come in the form of partial fraction. Again, we will apply the partial fraction concepts only. Already partial fraction problems we have done that in the differential equations in the Laplace transforms. The same concepts only we are going to use that the partial fractions, but here we are applying the inverse Z transforms. Right. So here we will solve the problems using what is that? Partial fractions. Right. Inverse Z transforms. Inverse Z transforms. Inverse Z transforms of rational algebraic functions of rational algebraic functions of rational algebraic functions by partial fraction method. By partial fraction method. I'll explain the procedure. So then we will simplify the problems. Right, this partial fractions is very important. One separate question will come. At the same time, in the difference equations also one question will come. Right, first step what we will do, given u bar of z equal to f of z divided by g of z, f of z divided by g of z, we need to express g of z in terms of non-repeated linear factors only. Non-repeated linear factors only. Suppose if it is repeated linear factors, I will tell how do you write that one in this. Right. Next step. We consider u bar of z divided by z in the form of proper fractions, in the form of proper fractions, I'll write here, see, proper fractions, in the form of proper fractions. Next, we multiply by z to have u bar of z involving various terms of the form c into z divided by z minus k. C is constant. That means A by B by you will write now. That's only I'm telling. C is constant. Right. Finally, fourth step. Finally, we compute the inverse Z transform of these. We compute the inverse Z transform of these. Inverse Z transform of these terms of these terms resulting in the required Z inverse of u bar of z. Z inverse of u bar of z. Right. Suppose already I told that if it is repeated, how do you do? If, say, this is note I am writing. If g of z involves repeated linear factors, repeated linear factors of the form z minus k whole square, z minus k whole cube, z minus k whole power 4, and so on. We need to take into an account of like this will come. We need to take account the corresponding inverse Z transform. Account corresponding terms in the numerator. First term, if z minus k whole square is that means in the numerator k z we have to take. Second term should be that k z square plus k square z. Another one should be k z cube plus k square z square plus k cube z plus k cube z, and so on. So we can write respectively and express u bar of z suitably and express u bar of z with terms multiplied by a comma b comma c and so on. I think understood. Whenever repeated factors comes, we should do z minus k whole square, z minus k whole cube, z minus k whole power will come means if z minus k whole square comes in the denominator, I will write k z. Z minus k whole cube come, I will write this one k z square plus k square z. If z minus k whole power 4 comes, k z cube plus k square z square plus k cube z and so on. Right. So this is the way of expressing the terms in the partial fractions. Right. Now I will take one problem. First I will take non-repeated I will do. Then at the end I will do repeated problems. This note will be applicable whenever that repeated terms comes. Repeated terms z minus k whole square comes, numerator k z has to come. Z minus k whole cube comes, k z square plus k square z. To simplify that, this is the things you should remember. This is very important whenever repeated terms comes. Non-repeated is very easy. So repeated comes, you should know this procedure. Right, next. In this one, we'll do problems. First problem in the partial fraction. First problem I'll take. Find z inverse of z divided by z minus 1 into z minus 2. Find z inverse of z divided by z minus 1 into z minus 2. Solution. Solution. So we'll take the given thing should be, we'll take it as let u bar of z equal to z divided by z minus 1 into what is that? Z minus 2. This is u bar of z. How do you write? See, already I told that this only I'll write u bar of z divided by z equal to u bar of z divided by z equal to 1 divided by z minus 1 into z minus 2. 1 divided by z minus 1 into z minus 2 I'll write. Now this only I will take it into the partial fraction concept. This one I will consider as equation 1, and next one should be, this is equation 1. Now next, what is that left hand side should we see now? U bar of z divided by z equal to, in next sheet I'll write u bar of z. See, what is that? 1 divided by, this one first we will simplify, 1 divided by z minus 1 into z minus 2 equal to, I'll write a divided by z minus 1. This only, if you want, you can write left hand side also u bar of z divided by z equal to 1 divided by z minus 1, z minus 2. This only I'll write a divided by z minus 1 plus b divided by z minus 2. Now I'll write u bar of z divided by z equal to, say z equal to, here what is that left hand side should be 1 is there. So you can keep it as it is. 1 equal to, what is that? A into, if you'll multiply this, z minus 2 you'll get plus b into z minus 1. Consider this is equation 2. And now here say this is, we'll take it as equation 3 we'll take. Now here put z equal to 2 in equation 3. If you'll put z equal to 2 in equation 3, 1 equal to, z equal to 2 means a term should be 0. Z equal to 2 means 2 minus 1 should be 1. So that equal to b equal to 1. Next, put z equal to 1 in equation 3. We'll put z equal to 1 in equation 3. 1 equal to 1, if you'll keep 1 minus 1 should be 0. 1 minus 2 is minus a equal to minus 1. A is minus 1. Now one should be b equal to 1, another one should be a equal to minus 1. Now where I can substitute a comma b in equation 2. We'll substitute in equation 2 u bar of z divided by z equal to 1 divided by, say this one only, a value should be what is that? This 1 divided by z minus 1 into z minus 2 is u bar of z divided by z. A value should be what is that? Minus 1. The value of a is minus 1. Minus 1 divided by z minus 1 I'll write, plus b is nothing but 1 divided by z minus 2. U bar of z equal to minus of z divided by z minus 1 plus z divided by z minus 2. Now I'll write z inverse of u bar of z equal to minus of z inverse of z divided by z minus 1 plus z inverse of z divided by z minus 2. Now I'll write, so minus of z by z minus 1 should be, what is that? Z by z minus 1, we will write it as, what is that? Already we know that the formulas, what is that? Z by z minus 1 should be z by, say, minus of z by z minus 1. Z minus 1 should be, we can write it as 1. This is plus 1 power n. Next one should be plus z by z inverse of z by z minus 2. If you see that formulas, z inverse of z minus 2. What is that? Z minus 2 means here k plus 2 is there. K plus 2 is there. So the time k plus 2 is there means what is that? You have to write 2 power n. 2 power n I'll write. So now here minus of 1 power n plus 2 power n. Now I can write minus of 1 power n should be 1 only. 2 power n minus 1 I will write. Now z inverse of u bar of z equal to 2 power n minus 1, which is the required solution for the given equation. Z inverse of this one I can write it as un equal to 2 power n minus 1 also I'll write. U suffix n equal to 2 power n minus 1 also I can write. This is the required solution for the given problem. Next, one more problem we will do in this. one more problem. Z inverse of Z Z divided by Z square plus 7Z plus 10. Right. So this is the next question. How do you simplify this? So using partial fraction concept. Now I'll take u bar of z equal to, right here, solution u bar of z equal to z divided by z square plus 7z plus 10. If I'll factorize this, I'll get in the form of, you can use calculator and you can factorize this. You will get in the form of z divided by z plus 2 into z plus 5. Use calculators and you can find it very easily. If you'll enter the quadratic equation in the calculator, it will show two roots. If you simplify that one, you can write in the form of factor form. Right, z plus 2 into z plus 5. Now, I can write u bar of z equal to z divided by z plus 2 into what is that, z plus 5. Now I'll write this one only, u bar of z divided by z equal to 1 divided by z plus 2 into z plus 5. 1 divided by z plus 2 into z plus 5. Now we can write this one only. I'll write u bar of z divided by z equal to a divided by z plus 2 plus b divided by z plus 5. Now I can write, what is that now? U bar of z divided by z is 1 plus 1 divided by z plus 2 into z plus 5 equal to a divided by z plus 2 plus b divided by z plus 5. Now I can cross multiply this. If you cross multiply a into z plus 5 you will get, plus b into z plus 2 I will get. Now this one should be C. I will take it as this is equation number 1 and this one should be equation number 2. Now put z equal to minus 5 in equation 2. We'll give z equal to minus 5 in equation 5. A into 0 plus b into minus 5 plus 2 is nothing but 1 equal to minus 3b, b equal to minus 1 by 3. Next, put z equal to minus 2 in equation 2. We put z equal to minus 2 in equation 2. B term will become 0. Minus 2 plus 5 is nothing but 3. So 1 equal to 3a. A equal to 1 by 3. A equal to 1 by 3. One should be B value. Another one should be A value. Now we can substitute this A and B values in the, what is that term? In equation 1. Now I'll write substitute A comma B in equation 1. We'll substitute in equation 1. We'll write u bar of z divided by z equal to, but that A is nothing but 1 by 3 into 1 divided by z plus 2. B is nothing but minus 1 by 3 into 1 divided by z plus 5. Z plus 5. Now we'll write u bar of z divided by z equal to, u bar of z divided by z is there. I'll write u bar of z equal to 1 by 3 into z divided by z plus 2. I'll write, just I am across multiplying the z that side, minus 1 by 3 into z divided by z plus 5. Now I'll apply inverse Laplace transform. Z inverse of u bar of z equal to 1 by 3 into z inverse of z divided by z. This one, see, I'll write minus of minus 2. I'll write minus 1 by 3 into z inverse of z divided by z minus of minus 5. I'll write. Now you will write z inverse of u bar of z equal to un equal to 1 by 3 into z divided by z minus of minus 2 is nothing but minus 2 whole power n minus 1 by 3 into minus 5 whole power n. I'll write. which is, what is that? Why I'm writing like this? Already formulas I told. The formula should be in this format, already I told. Z inverse of Z by Z minus K is K power N. Here I am writing Z minus of minus I am writing. What are the K values here? Minus 2 is one value and minus 5 is the another value. So that values I am substituting and I am simplifying here. This is the required solution for the given equation. Right. We'll simplify one more problem. One more problem in this non-repeated linear factors. Right. Find Z inverse of 3z square plus 2z, 3z square plus 2z divided by 5z minus 1, 5z minus 1 into 5z plus 2, 5z minus 1 into 5z plus 2. Now I'll write solution. Solution will take u bar of z equal to 3z square plus 2z divided by 5z minus 1 into 5z plus 2. Now I can write this one only. Here see, u bar of z divided by z equal to, see here I am taking z outside. Here what I am getting here, see, 3z plus 2 divided by 5z minus 1 into 5z plus 2. Now I can write this one only, 3z plus 2 divided by 5z minus 1 into 5z plus 2 equal to, I'll take, this is equation 1, you can take, this one only I'll write, a divided by 5z minus 1, b divided by 5z plus 2. Now we'll cross multiply this, we'll get 3z plus 2 equal to a into 5z plus 2 plus b into 5z minus 1. Now, what terms we'll substitute? We will get that means, so we can substitute, put z equal to, say this equation I will consider as, say this is equation 2 and this is equation 3. Put z equal to 1 by 5. Put z equal to 1 by 5 in equation 3. If z equal to 1 by 5 will put means, this one I'll write 3 by 5 plus 2 equal to, z equal to 1 by 5 means 5 get cancelled, a into, what is that, 1 by 5 means we'll get 2 plus 1 should be 3, plus this one should be, b term will become 0. Now we'll get 3 by 5 plus 2, 5 into 2 should be 10, 10 plus 3 is 13, 10 plus 3 divided by 5 equal to 3a. Now we will write a equal to 13 divided by 15. This is the value of a. A is nothing but 13 divided by 15. Next, similarly, we'll give, put z equal to minus 2 by 5 in equation number 3. We'll give minus 2 by 5 in equation 3. We'll get will give means we'll get out of that, a term will become 0, b term should be right. So if you substitute this, we will get 3 into minus 2 by 5, 3 into minus 2 by 5 plus 2 equal to a into 0, a into 0, a into 0 plus b into, we will get 3, b into 3 will get, So we'll get b into what are the 3 or minus 3 we'll get here. We'll put now minus 2 by means b is minus 3. Now if we'll simplify this, we will get b value, will get it as uh, b equal to, you can simplify this, you will get minus 4 by 15 you will get. This is the value of b. I found out a values and b values. I can substitute a value, b value in equation number, what is that term? In equation number 2. Right, substitute a comma b in equation 2. We'll substitute in equation 2. So what we'll get in equation 2 means, equation 2, 3z plus 2 u bar of z divided by z equal to u bar of z divided by z equal to a is nothing but 3 by 15. A is nothing but 3 by 15. 3 by 15 into 1 divided by 5z minus 1. 1 divided by 5z minus 1 plus b is nothing but what is that? B is minus 4 by 15 minus 4 by 15 into that minus 4 by 15 into 5z plus 2. 1 divided by 5z plus 2. Now this z I will cross multiply that side. So if we cross multiply that side, u bar of z equal to 3 by 15 into z divided by 5z minus 1 minus 4 by 15 into z divided by 5z plus 2. But if I apply inverse formula always, all the formulas you can see here, if you'll see, you'll come to know that all the formula starts with z coefficient should be 1 only. It may be a whole square, a whole cube, whatever it may be. So it may be a linear also. All the terms z coefficient should be always 1. So I have to make here also, you'll see z coefficient should be, what is there here? You'll see here z coefficient should be not 1 here. So to make that 1, so what I will do here, I'll take 5 outside, 3 by 15 into 5, that is nothing but z divided by z minus 1 by 5 minus 4 by 15 into, if I'll take 5 outside, z divided by z plus 2 by 5. Now I'll get, this is u bar of z. U bar of z equal to 3 by 75 into z divided by z minus 1 by 5 minus 4 divided by 75 into z divided by z minus of minus 2 by 5. Now, z inverse of u bar of z equal to 3 by 75 into z inverse of z by z minus 1 by 5 minus 4 by 75 into z inverse of z divided by z minus of minus 2 by 5. Now you'll write this is un equal to 3 by 75 into 1 by 5 whole power n minus 4 by 75 into minus 2 by 5 whole power n. I'll write minus 2 by 5 whole power n, which is the required solution for the given problem. Right. Now I'll do one problem. Up to here, 3 problems I have done, which is non-repeated. Now I'll do one problem in repeating fractions. In repeating fractions, I'll do one problem. Right. The problem, find z inverse of 8z minus z cube divided by 4 minus z whole cube. 4 minus z whole cube. Right. How do you write this one? So I'll take this one as, we'll take in the form of solution. Solution is u bar of z equal to 8z minus z cube divided by 4 minus z whole cube. This only you will write z cube, I'll write z cube minus 8z divided by z minus 4 whole cube also I'll write. Both are same. It represents the same only. We're taking minus common from numerator and denominator. Here say z minus 4 whole cube is coming. So it is, what is that? Repeated factors. So repeated factors. Repeated terms. Repeated terms. Whenever repeated terms comes, how we can simplify this? Repeated terms comes, how do you simplify this problem? Now, repeated terms comes. Already I told, how do you write? So in previous cases, see I'll show here, repeated terms comes. How do you write? Here I told. So z minus k whole cube comes means k z cube plus k square z divided plus k cube z like this. You outright. Here whole cube term is there. Whole square term will write like this, and linear term. See whole square term like this, whole cube term, and this is whole power 4 term. Here up to we are having, what is that? Whole cube term only. So that's the way kz square plus k square z, and next one should be whole square term. I'll write it as kz. Right. Now we can see here, I'll write, how do you write? First only I will arrange it. That time only it is very easy. I'll write here, see, first term, usually we'll write, we have, right here, see, we have z inverse of z by z minus 4 is nothing but 4 power n. Z inverse of 4z divided by z minus 4 whole square is nothing but 4 power n into n. Next, z inverse of 4z square plus 16z, 4 square I'll write, 16z divided by z minus 4 whole cube equal to 4 power n into n square. 4 power n into n square. Now we'll write, left hand side should be c, u bar of z equal to z cube minus 8z divided by z minus 4 whole cube I'll write. This only I'll write a into z divided by z minus 4 plus b into 4z divided by z minus 4 whole square plus c into 4z square plus 16z divided by z minus 4 whole cube. Z minus 4 whole cube. Now, what I can do here, see, I'm arranging like this. Already I told k is nothing but what is that here. First term, normally we'll write. Second term means what is that? According to that procedure, I'm writing k is z divided by z minus k whole square. K is 4. Z minus 4 whole cube is there. This one k is z square plus k square. K square is nothing but 16z divided by z minus 4 whole cube. Now I'll write z cube minus 8z divided by z minus 4 whole cube is there. This one only I'll write here, see, a into, I'll write, if you cross multiply also will get, first I'll write a is z divided by z minus 4 plus 4b into z divided by z minus 4 whole square plus c into 4z square plus 16z divided by z minus 4 whole cube. We'll cross multiply, see, at the same time, common term should be there z. I'll take the z outside, and left hand side, right hand side, I'll cancel. Z square minus 8 equal to, if we cross multiply this term also that side, we'll get a into z minus 4 whole square plus 4b into z minus 4 plus 4c into here, say 4z square plus 18z is there. So z minus 4 whole cube cancel means you have been taken already z outside. So if you'll z outside, if you'll take, you will get 4z plus 16 you will get. 4z plus 16. So this is the terms remaining. Now if we give, put z equal to, this is nothing but we'll take this equation as equation number 1 I'll take. This is equation number 2. Put z equal to 4. So if you give put to z equal to 4, if you give 4 square is 16 minus 8. 16 minus 8 should be 8. So a into 0. So next one should be b into 0, b into 0 plus c into, here c, I left out c term, into c I'll write here, c into, so if you give z equal to means 16, 4 into 4, 16, 16 into 16 plus 16 should be 32. So you will get 8 equal to 32c, c equal to, what is that, c equal to 1 by 4. This is the value of c. C value should be 1 by 4. Next, similarly, equate z square coefficient. Equate z square coefficient. Coefficient of z square. Equate z square term. Z square coefficient in both sides. In both sides of equation 2. If you equate means 1 equal to, what is the z square term? If you equate, what you will get? 1 equal to here z square means if you will expand z minus 4 whole square, you will get z square, that is a. A is nothing but 1. Next, also equate z coefficient. Equate z coefficient in both sides. In both sides of equation 2. If you equate z coefficient in both sides of equation 2, if you equate that one, you will get minus 8a plus 4b plus 4c equal to 0. If you equate means you will get b equal to, what is that? B equal to 7 by 4. This is the value of b. B is nothing but 7 by 4 you will get. Now I can substitute this a, b, c in equation number, what is that? In equation number 1. Substitute a comma b and c in equation number 2. If you substitute in equation number, not in equation number 2, in equation 1. In equation 1 you can do. In equation 1 if you do, you will get that equation 1 should be z cube right, z cube minus 8z divided by z minus 4 whole cube equal to a is nothing but 1, that is nothing but z divided by z minus 4, b is nothing but 7 by 4 into, what is that, 4z divided by z minus 4 whole square plus c is 1 by 4 into 4z square plus 16z divided by z minus 4 whole cube. Now we'll write z inverse of z cube minus 8z divided by z minus 4 whole cube equal to z inverse of z by z minus 4 plus 7 by 4 into z inverse of 4z divided by z minus 4 whole square plus 1 by 4 into z inverse of 4z square plus 16z divided by z minus 4 whole cube. According to the inverse Z transforms formula, I'll write this one should be 4 power n, I'll write plus 7 by 4 into 4 power n into n, I'll write plus 1 by 4 into, this one should be, I'll write 4 power n into n square. This is, already I took z inverse of z cube minus 8z divided by z minus 4 whole cube, which is the required solution. Now I'll write this one only, z inverse of z cube minus 8z divided by z minus 4 whole cube equal to, I'll write 4 power n plus 7 into n into 4 power n minus 1 plus 1 by 4 into, so 1 by 4 I am writing as 1 into 4 power n minus 1 into n square also I will write. This is the required solution for the given equation.